So it's a special type of a differential equation which is first order but higher degree. And when we solve a differential equation is solvable for y model, it's a special case. It is known as the Clairaut's equation or Clairaut's form, Clairaut's equation. And then how can I say a differential equation is a Clairaut differential equation? A differential equation is in the form y is px plus some function of p is known as the Clairaut's equation. That means it's a special type of a differential equation which is solvable for y, because we have already learned that solvable for y model is y is some function of x and p. Here it's a function of p and this one is p and x, therefore you can easily say that the right hand side should be a function of x and p. So the procedure of solution of a Clairaut's equation, just same as the solvable for y model, differentiating throughout the equation with respect to x, we find the left hand side y becomes dy dx px. When we differentiate x, it's become p, and when we differentiate p, it's become dp dx x dp dx, and if p, it's become f dash p dp dx. And in the dy dx is nothing but p, so p should cancel out. P should cancel out from both the side. This one and this one should cancel out from both the side. The remaining quantity of this equation, it's become x plus f dash p dp dx, nothing more. Okay, so when it's a product of two quantity, then either this one is 0 or that one is 0. If we consider dp dx equals to 0, then there is two different cases. Case 1, when we consider dp dx equals to 0, then p becomes a constant. When p is a constant or c is an any arbitrary constant, then substitute this value of p in equation 1, that means in the first equation. When we substitute p equals to c in the first equation, this is known as the general solution. That means you can easily find the general solution very easily when you solve a differential equation which is in the Clairaut's model. It should be a multiple choice question. Find the general solution of this differential equation without solving, without doing anything in this model, without doing anything of this. You can easily observe, you can understand. If you can understand, just to replace c by p by c, nothing more, we get the general solution. Okay, we get the general solution. So, and the another case is this one, and the second part, x plus f dash p equals to 0. That means we can find x equals to f dash p, and the given equation is in terms of x and p. So if we put x equals to minus f dash p in this equation, you can easily observe. If we make a arrow for you, this one, okay, from this, just to put the value of x in this equation, we get this result. Okay, minus p into f dash p plus fp, which is only a function of p, and this one is x is some function of p. And eliminating p from these two equations, we haven't any arbitrary constant, so it is known as, this solution is known as the singular solution. This solution is known as the singular solution of the given differential equation. If somebody asks you what is the relation between the singular solution and general solution, you just remember this word is, the singular solution is the envelope of the family of general solution. Singular solution is the envelope of the family of general solution. So this one is an example. Solve y equals to px plus a by p. You can easily observe this problem is solvable for y, and since there is a px, there hasn't any one term. I forget to save this one. When we consider the Claudius form, that should be px. It should not be p by 2x. It should not be 2px. It should not be p square x. Only for px, this equation becomes a Claudius equation. Okay. So here is an example exactly which is px, and the remaining part should be a function of p. I am not mentioning this function of p should be in that form or that form or other form. That should be always a function of p, nothing more. You should remember that the first term should be px and the remaining term should be a function of p. When when a differential equation is exactly in that form, then we say that it's a Claudius equation. The procedure of solution of the Claudius equation is just to differentiate both sides with respect to x, just to differentiate both sides with respect to x, nothing more. Just to differentiate both sides with respect to x, the result and y becomes dy dx, and this becomes p and x dp dx minus a by p square dp dx. P should be cancelled out from both the side. The remaining term x minus 1 by p square dp dx. dp dx equals to 0. Integrating both sides, we get cp equals to c is the constant, and we can easily find the general solution. This becomes y equals to cx plus a by c. When we consider the other term, x minus a by p square equals to 0, x equals to a by p square, and p square becomes a by x. If we put this value of p in equation 1, that means the given equation, we can find the singular solution of the given equation. So the singular solution becomes p becomes root over of a by x. So here we put p square. If we just make it as square on the both side, y square p square x square a square b square 2px plus a by p should cancel out. Just to put the value of p square here, the value of p square is a by x, that's why here we use a x by a, and x square a by x, and this one is y square equals to 4x is a singular solution of this given differential equation. You can just watch your 11-12 book. You can easily observe that y square equals to 4x, the general form of a tangent is y equals to cx plus a by c. Okay, you can recognize this one is for any tangent of y square equals to cx should be y equals to cx plus a by c, nothing more. So what is the concept of envelope? Here we make a diagram of envelope. Here we make a diagram of envelope. Sorry, envelope. B E A O, and this one is B, envelope. If we consider this one is your parabola, and the family of straight lines should touch this one. This family of straight lines should be this one, and the curve should be this one. The curve should be this one. This is your parabola. This is your parabola. This one is your parabola. Nothing more. This one is your parabola. Okay. So we take another example. This one, y x dy dx plus dy dx the whole square, differentiating both sides with respect to x, it's become p, and this one is dp dx equals to 0, p becomes c. If we put the value of c here, we get the general solution y equals to cx plus of x squared. The another factor is x plus of 2p. Here we consider x plus of 2p equals to 0. So x equals to minus 2p, p becomes minus x by 2. If we put this value in equation 1, we get the general solution. If we put this value of p in this equation, in this particular equation, we get the singular solution y, x squared plus 4y equals to 0. That is your singular solution. That is the procedure for finding the general solution and singular solution using Clairaut's method. In the next lecture, we give some more example of Clairaut's method, and another one should be very important. If a equation is not in the Clairaut's form, you can reduce this problem to Clairaut's form with a suitable substitution. And in the next lecture, we'll move to this particular topic. Thank you for listening.